This is Mrs. Naslund, and today we'll be doing Unit 3, Lesson 13, Too Large, Too Small, or Just Right. Today we'll be talking about estimating when we're looking at double-digit by triple-digit numbers, and we'll talk about when we overestimate and when we underestimate. So we'll start with underestimate. There's two ways to divide 764 divided by 15, and we're going to look at both these methods and see which one works best. So when I look at this problem, first thing they did is they estimated. They moved it up to 20, which is over what this number is. So they said, okay, if I was going to do 20 into 76, and they said, okay, I'm going to go with 4 because I've got 20, 40, 60, 80 is pretty close to 76, so we're going to say 4. And then I go ahead and multiply my 15 times my 4, and I get the 60. All right, and I subtract and I get a 16. So right now I know I underestimated this number because if I get a 16, I can get 15 into 16. So I know that this shouldn't be a 4, it really should be a 5. So this didn't work very well because my estimation, it's 5 away, and that made me underestimate by quite a bit, and that changed my answer. Okay, so let's try a different method. And this is when we're dividing. If I would run into something like this, I could change my problem to some expanded notation. So now in this case, again, I rounded it to 20. And I started with the same answer. So I said, okay, 20 into 76, it's about 4 because 4 times 20 is 80. That's close to 76. But when I actually multiplied it out, so if I do 15, and you'll see what they did here is that instead of just having a 4, we expanded it. I'm saying that I have 4 tens or 4D, and so they added that extra 0. And I'm going to do 15 times 40. Well, when I do 15 times 40, I know that 15 times 4 is 60, and so I add that 0 on, so I get 600. So I subtract 764 minus 600, and I get this 164. So now I'm going to keep using the same strategy here, and I'm going to look. I'm going to say, okay, I've got 15 here, and I'm looking, and I can see even if I use this 20, 20 into my 16, or my 15 into my 16, I know it at least goes in one more time. So I'm going to add one more 10 because it's in the 10 spot here. So I'm going to add 10 up here. Okay. So now let's go ahead and continue working on the problem. If I take 10 times 15, I would get 150. Let me get my writing tool here. I would get 150. And if I subtract those two, I would get 14. Now, 14, and now I've done all of I can't get any more 15s into 14, so I know that's my remainder. So what I do here is I add these sets of 10, so 40 plus 10 is 50, and my remainder is 14. So when I use the expanded notation, it allowed me to continue to go. Even though that I underestimated, I was able to keep adding on 10s until I was able to get to my answer and get a remainder. So let's read this together. And this I know is the answer, but I think it's important for us to understand it. It says, when we estimate with a number that is too big or we overestimate, we have to erase and change the number. When we estimate with a number that's too small or we underestimate, do we always have to erase? And what we learned is that we don't. If we're doing it one digit by one digit, yeah, we're going to have to erase it. But if we use some expanded notation, so we write them as tens instead of just single digits, that we're able to keep adding them on in order to keep doing it. So here's what it says. We have to erase the digit by digit method, but do not with expanded notation. With expanded notation, we can keep building the quotient and just add the numbers together at the end. So let's go ahead. I know these have the answers, but we're going to go ahead and try a couple of these together just so that we can get some practice with it. So in this case, I would change, I'm going to just rewrite this here. I've got my 28, use our box method that we like to use so much. 28, we have 86, and 8. So I look at this, and I'm going to estimate this one to 30. And about how many 30s go into 86? Well, if I rounded this to 90, right, because 86 is closer to 90, and I think, okay, 30 into 90, 30, 60, 90, I get about 3. Okay. Or I guess I could say 30. And then when I multiply my 28 times, or my 28 times 30, if I do 28 times 3 over here, oops, times 3, let's do that right there. So I get my 8 times 3 is 24, so my 4, carry the 2, 3 times 2 is 6, 7, 8, so I get about 84. And since we're adding that 0 on, we'd get 840. All right, and I do my subtraction here. And 8 minus 0 is 8. 6 minus 4 is 2, 28. So then I'm like, okay, well, I can look here and I can just see, I could take my 30 into my 28. I'm going to get it about 1 time. And now I'm in the ones place because I've moved over here to the 1 slot. So I'm going to put 1 up here. And 28 times 1 is 28. I get no remainder. 28 minus 28 is 0. So my answer is 30 plus 1, which is that 31 that we were looking for. Okay. All right, let's try another one. Let's go ahead and try this one. We have 17 into 897. So we're going to rewrite that, 17 and 897. 897. And I'm going to estimate my 17 to 20. And we'll say, okay, how many 20s go into 89? Well, 20, 40, 60, 80, so about 4. And then I do my 17 times 4, which I've already figured out for us. 17 times 4 is 68. Okay, so I'm going to go ahead and write my 68 here. And we'll go ahead and subtract it here. So 9 minus 8 is 1. And 8 minus 6 is 2. All right. So I've got my 21 there. And now I'm going to go ahead and say, okay, how many of these 20s go into 21? Well, I get about... All right, so I'm looking at this and I realized that I didn't write my 0 here for 4D because we're trying this expanded notation since we know that it's not going to quite work. So then I think to myself, okay, can I get another whole 17 or 20 into 21? And I can. I can get how many more? Get 1 more. So I'm going to add up a 10 up here. All right, and then I go ahead and do my multiplication. So I'm going to do my 1 times my 17, and I get 17 here. Go ahead and subtract. And 21 minus 17 is 4. All right, so now I'm down. I can't get another one in there. So now I'm going to bring it over to my ones column here, and I have 47. And I'm going to say to myself, okay, how many 20s can I get into 47? Well, I can get 2, and now I'm in the ones column, so I'm going to put the 1 up here so I can get 2. And now I do my 17 times 2, which gives me 34. Now I subtract, and this will be my remainder because I'm in the ones column. So 7 minus 4 is 3, and 4 minus 3 is 1. So I have a remainder of 13. And then I just add these up. So let's see if it worked. If I do 40 plus 10, I get 50, plus 2, I get 52. Remainder of 13, which is exactly what the answer is. So expanded notation works well when you're estimating, especially if you have an underestimate. That concludes my lesson for today.